That's one way to tell if a battery's good or dead. Those are the words we use, good or dead, when we're talking about batteries. Dead actually refers to the fact that there's just as much electrical charge on one terminal of the battery as there is on the other terminal. Both sides have about the same amount, so there's no net push of charge in one direction or another. Good, on the other hand, means that it is charged. That means that there's more electrical charges on the positive terminal than there are on the negative terminal. In this way, you can create an electrical pressure that causes these charges to flow, carrying their energy. The concept of induction is still charging, but it is charging without contact. Friction is the transfer of charge by contact. Transfer charge by contact. Induction is without contact. And this is pretty cool. All right, so we begin with induction. Okay, induction. And induction is transfer without contact. I didn't mean to put that in a square. It meant to be in a circle. Without contact. Okay? So friction was charging with contact, or the transfer of charge with contact. Induction is transfer of charge without contact. Well, how, might you ask, do we transfer charge without contacting it? For that, we focus on the behaviors of charge that we learned in the previous lesson. Check this out. We have here, okay, never mind the fact that they're in corn. I've got two insulating rods with two conducting spheres on top. Okay? They're two conducting. It's got conductive paint on it. Okay? This over here is our standby rubber rod, and I'm going to charge it negative right now. Okay, it is now charged negative. These two spheres, because I'm touching them, are grounded. I'm grounding them. So these two spheres right here are said to be then neutral. There's as many positive charges on them as there are negative charges. Well, you have seen when we bring a negative rod close to a neutral object, if you remember the aluminum can demonstration, that in both cases, it attracted. Whether we used a rubber rod or a glass rod, the can attracted. So we can show that these are both neutral by the fact that they attract this rod. Okay, so you can see that that one attracts. And we'll bring it back. Come here. All right, and you can see that this one attracts. All right, so we have a negatively charged rod that's suspended over here. And we have two neutral spheres. Now what I'm going to do is bring them side by side, touching each other. So they are side by side and touching. Side by side and touching. That's important. Now I'm going to take another rod, charge it negative, and here we go. Now, by charging this one negative and bringing it next to these conducting spheres, what we see here is that all the positive charges on the spheres will migrate to the negatively charged rod, and all the negative charge on this sphere on the right will migrate to the one on the left, trying to get as far away from it as possible. So I hold the rod next to but not touching the sphere on the right, and then separate the spheres. Okay, I've separated the spheres. Now if this rod is charged negative, then this sphere must be positive and this sphere must be negative. So this sphere right here, when brought in contact or close proximity with the rod, should attract the rod. Okay, and there it goes. You can see that. Okay, come here. Slow down. Okay, now this sphere has been charged negative, which means it should repel this rod. So There we go. Is that not cool? We have charged these two spheres using a property called induction. And induction, recall, is a process of transfer without contact. I did not move or touch this negative rod to that sphere to get it negatively charged, nor did I touch the fur to either of the spheres. Okay, there was no direct contact, no direct transfer of charge by friction. Okay, and this process is called induction. Pretty cool. Now, let me go back and make drawings of what we've done right here. Okay, what we've done. So, as we look then, we'll draw pictures of those two spheres. Okay, we'll make pictures of these two spheres right here. And in the beginning, the two spheres will be touching. Now, they're neutral in this case, which means there's, I should probably count them here. 1, 2, 3, 1, 2, 3, 1, 2. 1, 2, 3 negatives, and 1, 2, 3 negatives. Okay, they are neutral in every way. There's as many positive charges on each sphere as there are negative charges. So they're touching and they're neutral right now. Okay, now I take or consider these two spheres, but in this case they're still touching, but now I bring a charged rod up to these spheres. Now when they're neutral, what we observe is that all the positives come over here, 1, 2, 3, 4, 5, 6, and all the negatives then, 1, 2, 3, 4, 5, 6, run over to the other sphere. Because these spheres are conductors, they enable or allow charge to move on their surfaces. Okay, now they're touching. Now I keep this in proximity. Okay, I keep the negatively charged rod in proximity of the positive sphere, and I separate the two. Okay, I separate the two spheres. So we went from neutral to inducing. This is called induction. Okay, this is where we're using the behaviors, the properties of electric charge to cause an attraction of the positive and a repulsion of the negative. And so we're inducing a charge separation right here, and then we separate the two. Okay, and then by removing the rod, it's taken out of the picture, we see that the charges then evenly distribute over the surface of these conductors. Why? Because they are conductors. They allow the charge to move out. And these are all negatives, so they're going to repel across from their neighbors, to evenly distribute themselves on the surface here. The positives are going to evenly distribute themselves by repelling all over the surface. So you see how the property and principle of induction has worked. So we've gone from friction, which is a physical transfer, a direct contact of charge being moved from one material to another material, to induction, which is the movement of charge, the separation of charge through properties of and behaviors of charge. No contact. So this idea of charging right here is a very, very cool idea of charging because it takes no contact. Well, there's another way of charging an object by induction, and it's called induction by grounding. So let's show some demonstrations on how and what it means to induce a charged object or induce an object to be charged by grounding.